Okay, so we're recording now. All right. So again, I'm going to do a little stare and compare. So my A in this case is the number 4. The number 4. Okay. And my X is the part that I don't know. And my Y is the number 3. So again, what I'm going to do, I'm going to rewrite it in exponential form. So my A is the number 4 to the power 3 is equal to X. And now I can just solve for X. So I need to figure out what's 4 to the third power. So 4 to the third power means 4 times 4 times 4. And that's just 64. So really for every one of these problems, I'm looking at what's the definition of a logarithm? And if it's given to me in the logarithm, what I'm really doing is I'm writing it as an exponent or writing it in exponential form and then looking for that missing piece, okay? All right, so let's do a little bit more of properties of logarithms and then we'll go ahead and move on to some stuff out of 4-6. So properties of logarithms, guys, remember what we're talking about. We're thinking about exponents, right? So I want you to think about this one here, the product property. Think about if you're multiplying two numbers with the same base. What do I mean by that? If you're multiplying something like this, x squared times x to the third, what do I do with my exponents? We add them together, right? The quotient property, think about that, x to the 7th over x to the 4th. If we're dividing two numbers with the same base, what do we do with the exponents? We subtract them. That's what we got right here. If I have a power that's being raised to a power, what do I do with my exponents? We multiply them. If I have that power, I'm multiplying it right there, right? Okay, so I'm going to walk you through some properties here, and we're going to see if we can't figure this part out. So it says, use the properties of logarithms to rewrite each expression, simplify the result if possible, assume all variables represent positive real values. Okay, so first thing I'm going to do, think about this in parentheses because you're taking the logarithm of the whole thing. And we have here a fraction. Remember what a fraction means? I'm subtracting, right? So I'm going to rewrite this as the log 2 of 6x minus the log 2 of y. And then think about the next part. What is 6 and x being doing? They're being multiplied. So if I'm multiplying, remember when we're multiplying, that means we're going to add our exponents. So I'm going to rewrite this as the log base 2 of 6 plus the log base 2 of x minus the log base 2 of y. Okay. And then I would stop at that point right there. Okay. And so for the next one, I'm going to go about it exactly the same way. So I'm going to think about this as being in parentheses, okay? So remember we said if we're dividing, we're going to subtract. So I'm going to rewrite this as the log base 5 of 5 square roots of 7 minus the log base 5 of 3. Okay. And then I'm going to do the same thing here. I'm going to think about this as being multiplied. So I'm going to write this as the log base 5 of 5 plus the log base 5 of the square root of 7 minus the log base 5 of 3. And then there's another property, guys. And so I'm going to scroll back down over here so we can see it. And here we go. It says, if I have the log and the base number and this number are exactly the same, it's equal to 1. So as I scroll over here, I want you to notice this number and that number are exactly the same. So that part right there is going to be equal to 1 plus, and again, I'm going to write this out. I'm trying to go step by step so that you can see what I'm doing. 7. I know it's 7, the square root of 7, but I can write that as the power of 1 over 2 minus the log base 5 of 3. And then the last thing I'm going to do here, if I have an exponent here, I can bring that exponent down to the front. And so what we're doing in these particular problems, y'all, is we're taking a logarithm that is condensed and we're expanding it into like a whole other piece, right? Okay, so then for the next one here, we're just going to be going backwards. Okay, we're going to be going backwards for this part. So I'm going to zoom in a little bit so you can see what I'm referring to. So in doing something like this, I'm going to kind of group them this way. And notice what we're doing here. They're being added. So if they're being added, that means we're just multiplying them together. Okay. And then now, if it's being subtracted, then what we're doing now is we're dividing it. Okay. Alrighty. And I'll do the same thing for the next one here. Now, what I'm going to do, I want you to notice I have a minus sign here, y'all, and I have a minus sign here. So look, let's write it like this. I'm going to factor out that negative, and I'm going to write it this way. Oops. That's an N, and that's a T. So all I did is factor out this negative from both these parts. Okay. Now, the reason why I want to do that is because I know that when I'm adding them together, that means that these two guys here are being multiplied. Okay? And now I can say, well, look, when I'm subtracting, what does subtracting mean? Subtracting means that we are now dividing the whole thing out. And we are done. Okay. So, and there's a little bit more here with you know, 4.3, but I definitely want to spend a little time on 4.6. So let me kind of hold off on some of this part here. And it was just those two problems, but let's go ahead and scroll over to 4.6 and let me see. So Vivian, I know you said you had some questions out of 4.6. Was it notes that you wanted me to go over, or was it like homework, a particular homework problem that you wanted me to do out of 4.6? Whichever one you want, I'm good with. But we can definitely figure that out.
Yeah, no, just I guess yeah, just the homework, just one homework question, and then that would be good for me.
So one from here, or one from the actual homework in my lab?
The actual homework from my
Okay,
lab.
cool. Yeah. Okay, definitely. Let me pull that up, and we will see what I can pull up here. Okay. Here we go. All right, yeah, definitely. And there's, guys, I want y'all to notice something. So let me stop sharing this here. And let me see. So guys, let's see, it should be pulling up now. Yeah, if you notice out of 4.6, we only got 3 problems there, right? So 4.6 is a pretty short section. So let me take a look and let me pull up a problem here out of 4.6, and we will definitely do one. So let me see, this right here. Okay, so I'll tell you what I'm going to do. Stop sharing this one. Let me share one more. Here we go. Okay, so guys, this is problem number 1 out of 4.6. And what I'm going to do here is, let's see. me stop sharing that. And all I'm doing here, y'all, is I just copied and pasted that problem, yeah, here into my notes. So same exact problem out of 4-6. We'll go through this one here, and we'll see if it makes sense. And guys, we'll even check our answer in real time so you can see that I'm shooting you straight here. I'm not making up stuff as I'm going through these problems. So let's take a look at part A. So this is the number 1 out of 4.6, and it says a sample of 500 grams of radioactive lead-210 decays to polonium-210 according to the function. Okay, so I need this piece right here. This is really important for me. 500 e to the negative 0.032 with a t. Okay, t is the time in years. And part A says find the remaining after 4 years. Okay, so guys, since t stands for the time in years, and we're going to figure it out on part A for 4 years, really what we're trying to find is a of 4. And I'm going to show you all here, guys, that this is going to be very much, oops, this here is going to be very much a calculator type problem, okay? So I want you to notice what I wrote right here, okay? And so what I'm going to do is I'm going to get my calculator going, and I'm going to share that part with you guys so you can see exactly how it is. I'm going to type this in. So I'm really, guys, what I wrote here in blue, that's what I'm going to type in on my calculator. And so what I'm going to do, pull this up, here we go. And let's see, I think you guys can see my calculator already. Okay, so what I'm going to do, I'm going to type in 500, okay, times, because there's a times, and then there's that E thing, right? So guys, the way I'm going to get to my E, I want you to notice right here where my number 4 is, if you look to the left of my number 4, there's an ln, and right above that ln, there's an E. So I'm going to go second, ln, and I'm going to type in my exponent exactly as I had it. So I had a negative 0.032 times 4, okay? I'm going to close those parentheses off, and I'm just going to hit enter, and I'm coming up with 439.90 something, or 92.6. So 439.93, I don't know how many decimal places I need to write. 439.93. Okay, so I'm going to stop sharing that. I'm going to come back to what I wrote down on my paper, 439.93, and the directions are telling me to round to the nearest integer. So guys, if I was going to round to the nearest integer, I would say 440 grams, right? And because it's 39.93. So now, if I come back to my actual problem, okay, and here we go, and I'm going to type in 440, and I'm going to hit enter, and woo, we got the first part right. Okay, now we're going to do part B. Part B says, what about after 6 years? Okay, so I'll show you how we're going to do that after 6 years. Okay. So part B says, what about after 6 years? Well, I'm going to do the same thing we did before, but now, instead of putting a 4, I'm going to put a 6, right? So I'm going to stop sharing that piece with you guys, and I'm going to share my calculator again so you can see exactly how I'm entering this in. And so guys, one of the cool things that you can do on your calculator, and it works whether you have a calculator like, whether you actually have like the TI calculator or whether you're using that app, one of the things you can do, instead of retyping everything, just hit second and enter, and it types in exactly what you typed in before. And now all I'm going to do is I'm going to change that 4 to a number 6. I'm going to hit equals, and I'm coming up with 412.65. So let me stop sharing that and come back to my notes. And we were coming up with 412.65. So if we're going to round up to the nearest integer again, we'd be typing 413. And so when I come back to my actual problem, And here it is. So right here, I'm going to type in 413, and I'm going to go chickadee check. Perfect. And then we're going to do this one last time for 10 years, okay? So guys, I'll tell you what I'm going to do. I'm going to stop sharing this, and I'm just going to come back to my calculator because you know that's really what I need. And let's see. Here we go. So I'm going to go second entry, and I'm going to change that 6 to a 10. So I'm going to type in 10, and I just got to close my parentheses because it erased it. Hit enter. And again, I'm still rounding to the nearest integer. So if it's 363.07, I'm just actually going to type 363, right? Because it's an 07 at the end. You wouldn't round it up. So 363. And so when I come back to my problem again, here we go. We're going to type in right here 363. And excellent. And now we're going to do the last part. The last part is asking us something that's about something called the half-life. Okay, so I'm going to walk you through the steps on how do I find the half-life of something. Okay, so where are my notes? Here we go. Okay, so when we're trying to do the half-life, the original equation we had was this one right here. Okay, the half-life means time it takes, come on, pen, to reach half of our initial amount. Okay, so what I want to point out, guys, we're looking, in this case, we're looking for time. So this is the letter we're going to solve for. Okay, how long does it take to reach half of the initial amount? So look at how much we started off with. We started off with 500. We want to figure out how long is it going to take to get to half of that. That means the amount that I'm going to have is now going to be 250 is equal to 500 e to the negative 0.032 with a t. Okay, so now I'm trying to solve for the letter t here. The first thing I'm going to do, y'all, I'm going to divide everything by 500. So this is going to be 0.5. Guys, think about what 0.5 is. 0.5 is the same thing as half, okay? E to the negative 0.032 with a t. All right, since I'm dealing with the base of e, the way I'm going to get rid of my, or I'm going to solve this thing, is I'm going to take the natural logarithm on both sides. I'm going to take the ln on both sides. So this is going to leave me with an ln of 0.5. Now, when we were doing that problem earlier, we were doing a problem earlier today. I don't know if y'all remember it. And it was like the log base 5 of 5, and those canceled out. The same thing happens here, guys. The ln and the e are going to cancel each other out. And I'm going to end up with a negative 0.032 with a t. And so now to solve for the letter t, what I'm going to do is I'm going to divide by negative 0.032 on both sides. So we're going to get t is equal to the natural log of 5 divided by a negative 0.032. This right here, y'all, is what I'm going to type in on my calculator. Okay, so let me share my calculator with y'all so you can see what I'm doing. So let me pull that up. Here we go. Let's go to the calculator. 36. Here we go. Okay, so I'm going to clear. Oops. I'm going to clear my screen. And so I had the natural log. So right here next to my number 4 is a natural log of 0.5. Right, it was a 0.5 divided by a negative 0.032. 0.032. And my answer, guys, should be positive, okay, because I'm looking for the number of years. So time can't be negative, right? So if you notice here, I'm coming up with 21.6608. And I'm just going to check something real quick. And it's asking me, the directions are telling me to go to 2 decimal places, okay? So if I'm coming up with 21.6608 to 2 decimal places, I would just write 21.66, right? So let me stop sharing this and let me come back to my actual problem, which is right here. And if you notice right here, guys, it says round to 2 decimal places. So I'm going to type in 21.66, and I'm going to go chickadee check, and we got it, right? And so this is pretty much what I'm doing in 4.6, okay? So guys, the one thing I really wanted to emphasize is, so if you look at this one here, this is just like the one that we did, but now it's just asking me for the half-life, okay? It's just asking me for the half-life. And I'll tell you what I'm going to do. I'm going to set it up for you all so that you know how to do a problem. Like it didn't give me an initial amount, right? It didn't tell me how much we started off with. And so if we don't know how much we start off with, how would we do it? I'm going to show you right now so that you know. So let me stop sharing that. Come back to our notes. Here we go. Okay. And start a problem mode. Okay, now this here is just, I'm sorry, go ahead.
Yo, what's up?
You have a question?
Oh, sorry.
Did you have a question?
Oh, no, sorry, I just accidentally answered.
Okay, it's all good. All right, so guys, how do I find the half-life if I don't know how much I have to begin with? Same way we did before. Okay, so A of t, excuse me, equals our initial amount, and it's negative 0.0199t. Okay, so the initial amount would be half of this amount here. So I'm going to write half of that amount. Okay. Now the first thing I'm going to do is I'm going to go ahead and divide by whatever that initial amount was. And notice those are going to cancel. And guys, remember, I wrote it here as a fraction, but you can definitely write it as a decimal. 0.5, right? Equals e to the negative 0.0199t. And now we're at the same spot where we were a little while ago. So we can say, look, how do I solve this now? We're going to take the ln of 0.5 equals the ln of e to the power negative 0.0199t. And this ln and that e are going to cancel out. And I'm going to have the natural log of 0.5 equals negative 0.0199t. So when I divide by this negative 0.199 on both sides, right? And this is the part right here, y'all, that I'm going to enter in on my calculator, right? So let me pull up my, oops, sorry. Let me pull up my calculator again. And so I'm going to stop sharing this piece. And I'm going to share my calculator with you guys one more time. Okay, so let me turn it on. And guys, we can even do the same thing we did before. We can go second entry. And the only thing that was changing was this part right here, and it was a 0.0199, right? And I can hit enter. Oops, something didn't go right. Let's see if where did I make a mistake? Too many decimals. Get rid of that. There we go. So negative 0.0199. Okay. And now just hit enter. and I'm coming up with 34.8315. And I'm just going to check one thing in terms of my, oops. Okay, so give me one quick second so I can stop sharing this with you guys. So guys, if you notice on my calculator, 34.83, right? That would be 2 decimal places. So if I stop sharing that and I come back to my actual problem, and the number we came up with was 34.83. And this one is actually telling me to go to the nearest tenth. Tenth means we just want 1 decimal place. So I'd write 34.8. I'll hit chickadee check. And there we go, right? So again, you can see, guys, that the problems are pretty much the same type ways, right? And I'll give you a hint on this last one. I want you to notice what, let's see, what T stands for. T stands for the time in days, right? So when I look at part A, it's 2 days. I'm just going to put a 2 where my, and when I do part B, it says 6 days. I'm going to put a 6 where my T's to be. What would I put for part C if part C says 2 weeks? What value of T would I use if T is my time in days? Anybody know? What value of T would we use for 2 weeks? Anybody know for 2 weeks? How many days are in 2 weeks?
14.
14. And there you go. And that's exactly what you would put for part C. Very good, perfect. So, so I'm hoping that we did problems 1 and 2, and for number 3, all you're going to do is you're just going to evaluate that function at 2, at 6, and then again at 14, right? So I'm hoping that that makes some sense, a little bit more sense at least. Were there any other homework problems that y'all wanted me to go over? We still got about 10 minutes. I don't know if anybody still has any other homework questions or anything. And then guys, remember tomorrow at 6:30, I will be taking time to answer questions out of the review. So if you have any questions out of the review, I would definitely encourage you guys between now and tomorrow, try to do as much of that review as possible so that tomorrow night we can answer any questions you guys might have. Are we good?
Yes, thank you for answering my question.
Oh yeah, definitely. No, I was happy to. All right, so guys, I'll tell you what, we'll go ahead and stop here. So let me stop sharing that, and let me stop